Now this example is the one that's going to make I think make that idea of what we're squaring equal to 0 very useful. So let us consider the example of y is equal to x minus 3 squared and see how this helps us with the parabola. Now we agreed that if we kind of think of what squared is equal to 0 will give us 0 out in general. So here's this idea that something squared equal to 0, well, this stuff in here would have to be 0. So in order to get 0 out, I would have to have 0 be all of the thing that was squared. So we could ask ourselves what would make x minus 3 equal to 0, and that's going to be x equals 3. So at 3, I should be getting 0 out of this thing. Now let's take a look at the HK form and make sure that that makes sense as well. So right now we have y is equal to a times x minus h squared plus k. And in our problem there is no k, so k is 0, so the y coordinate of the vertex should be at 0. This h is 3, so I should be at 3, 0. And this makes sense with this idea of what I'm squaring, that it would be all of these things equal to 0 to get 0 out. So our new parabola should be shifted over, the old one sitting there is now shifted over to 3, 0. And the HK form, this fancy idea, matches up with just some basic thinking as well. And I hope that by the time the video is done, that you won't be worried about this form, but you'll in fact understand it. Not something to be memorized, but something that just matches with the thinking you already have. And that seeing why the vertex of the parabola is at 3, 0 will make total sense to you. Now this is a special case for me, because I think that this can make a lot of sense if we consider what's happening when we multiply a times x squared, but very often people use language that's a little funny. So you're going to hear people say that when they see this graph of y equals, say, 3x squared, they're going to say that this is a thinner parabola. And indeed it's going to look thinner, but I hope that you'll understand that really I'm taking what I got out of this squared part and multiplying it by 3. So oddly enough, instead of saying that I have a point which is, we start at 0, 0 still, but we still start with 1, and there's 1 squared comes out, and times 3 is 3. Now the old point used to be 1, so in point of fact it's getting taller. And I would like to think of this as a vertical stretch, making it taller rather than thinner. So follow along as we go here. So here is our original y equals x squared. And what I'm going to do is suggest to you that when we multiply by 3, that we're really taking the y-coordinate and we're multiplying this little height here by 3. And so we end up at 1, 3 instead of 1, 1. Now 0, 0 doesn't go anywhere. And then the point negative 1, 1 goes to negative 1, 3. So when I graph this new graph, which is 3 times x squared, you will hear people describe this as thinner. But I hope that you'll understand it, that in point of fact it's just taller. It's been stretched tall, a bit like some kind of a machine pulling on it vertically, as opposed to squishing it horizontally. Now, this did not change where the vertex is, because when we consider the HK form, there was x minus h, well there's no h, and there's no k, so we're still at 0, 0, and indeed the vertex is at 0, 0. Well, now it's time to put it all together. So let's consider a complicated version of our problem, and this is going to be y is equal to 3 times x minus 5 squared plus 4. And let's see, I'm going to suggest again that you hit pause on this video and see if you can't sketch this parabola by using the idea that whatever in here is squared, when it's 0, that's going to give us the lowest point for this regular looking parabola, that the adding of 4 is going to move it up, and this 3 is a multiplier on how tall it is compared to its original shape. So go ahead and do that. And alright, well now imagine you're back. So let's consider order of operation here. That's very important as well. So the first thing that we need to look at is the original parabola. The original parabola is sitting right in here, and it's been moved over 5, so that h is 5. Now, the next thing that happened was that it was stretched. So we're starting with a basic parabola. There's x squared. We're then shifting this parabola over 5. So now we have x minus 5 squared. Then we've decided to stretch it by 3. So I'll just draw that in the same place. I've just made it a taller one. So that guy in there is, that green one is 3 times x minus 5 all squared. And then we decided at the end to raise it up 4. So our final version of this parabola has a vertex at 5, 4. So about 5 over and 4 up. And it's been stretched, so it's quite tall compared to our old parabola. And there we have it. So that is 3 times x minus 5 plus 4. And when you draw a parabola for your own help and for your teachers, I'm sure, we're going to want to make sure we write down what that actual point is so we are clear what we've done. And I'll even put some arrows on here so that it looks quite nice. And this should catch up with us in just a second. I'm running a little slow today. So the next thing we'll be doing, and I'll preface this, is trying to imagine what happens when we make these numbers a little different. So instead of having nice numbers that I've given you, positive 3 and this positive 5 idea for shifting, and a positive 4, what happens when we make this negative, or if we fiddle around with these ones as well. So that's coming up on the next example. Now let's extend this idea to make sure we could do this with any numbers we like at all. We've been very kind to ourselves using mostly positive numbers. So let's practice with something like y is equal to negative 2x squared. Now that negative is going to take whatever I got out of x squared, which I multiplied by 2, it's going to make it negative. So again, an original parabola might have been looking like this, with points, say, 0, 0, 1, 1, etc. Now this 2 is a multiplier on there, so it might stretch it up and down, but it doesn't have any major impact on the shape of it. The negative, though, is going to mean instead of getting something like 1, 1 in my axis here, instead of 1, 1, I'm going to get 1, negative 1. So when I graph this one, I should end up instead with the parabola going, let's give it a different color so we're clear, with the parabola going upside down. So the general idea would be that this is for a greater than 0, and this is for a is less than 0. Now I'm going to go for one all at once here and see if this doesn't make sense. And if it is a little bit, if you're a little uncertain, then go back and look at the earlier parts of the video. But here would be a possible example that would put a lot of trickier things in there. So let's have a negative 4x plus 3 minus 2, and we'll square all of this. Now the h, that's funny, because usually it's x minus something. So I have to have x minus a minus number to make this work. So really, when I look in that spot, that means that h is equal to negative 3. Now plus a k, well I have to plus a negative 2, so k is equal to negative 2. Now my a, the 4, is stretching it up and down vertically, and negative, though, is going to make it go downward. So I should have my vertex at negative 3, negative 2. Let's do that. So about negative 3 and negative 2, about there. And it's going downward. So there is my downward facing parabola. And it's been stretched. So when we go over 1 a little bit, instead of going down 1, we're going to be going down 4. So if this point here is negative 3, comma, negative 2, when I go over 1 more, negative 4, instead of going down 1, I should be going down 4, so I'll go down to negative 6. And one can see that it's been vertically stretched in that direction. Now if you've got this idea here, then there's pretty much nothing you can run into with y equals hk form, a parabola in hk form that you can't do. So best of luck to you, and look forward to seeing you in the next video.